This tutorial is a basic tutorial on just how to read basic solubility curves. So in each of these cases, we're going to be looking at a solubility curve. Now, a solubility curve, typically on this axis, will tell you how many grams of solute, which is the thing you have the least amount of, are going to be put in 100 grams of water. So that's this axis. This is 60 grams, 80 grams, 120 grams, and so on. On the bottom, you have a certain temperature. And so at different temperatures, you can look at how the saturation of any compound in water will behave. When you look at this solubility curve, you might notice a lot of these chlorides, these are all solid salts, solid solutes that are going in water. As you increase the temperature, the solubility tends to go up. Each of these curves determines this, or at least plots, the saturation point of each of these salts in water. If you have a gas, however, gases tend to decrease in solubility as you increase temperature. Let's look at that for just a second. If you have a solid in liquid solvent, such as you're putting sugar in your tea, if you put sugar, which is a solid, in your tea, which is a liquid, and you heat up the tea, the sugar, you can put more sugar in a hot tea than you can put sugar in cold tea. So if you have a solid solvent, you tend to be able to dissolve more as the temperature goes up. So that's what these curves will show. If you have a solid solvent, like this is a salt, sodium chloride, if you have a solid solute, then as you increase the temperature, you can fit more and more of that solid in the solution. This is your salt. Think of this as your sugar in your tea. As the temperature goes up, you heat it up and up and up and up. You can add more solid solute in that solvent. Same thing here. However, in a gas, it behaves differently. Think of your sodas. If you have a cold soda, you can fit more gas, shove more gas in that soda. You can make more fit in there. And it will fit in there rather than if you have hot soda. When you tend to have hot soda, the gases get a lot of more energy from the heat, and so that the gases will escape the soda and run away. Okay, so your gas curves are going to look like this. So when I'm heating up my Coca-Cola, for example, there's going to be less and less of that carbon dioxide that's going to fit in that Coca-Cola. But if I cool the Coca-Cola, more of the gas will fit in that solvent. So let's just start looking at some of these curves. Now the first key is to remember that if you're right on the curve, if you're touching the curve, then your solution is completely saturated. If you're at a point above the curve, whatever curve you're looking at, then the solution is supersaturated. Think of Superman jumping tall buildings, right? He's above the buildings. If you're below the curve, however, you're going to be unsaturated. Think of un as under, so underground or under the curve. It kind of makes sense. So let's do a couple of examples. The main thing to remember is that you're looking at the right curve. So in this case, we're looking at ammonia. Ammonia is a gas, and we're going to determine at 75 grams and 20 degrees C, where am I compared to the curve? So 75 grams is here. At 20 degrees C is here. So the point at which I'm looking at for 75 grams and 20 degrees C is this point right here. Now I want to take the point that they've just given me, 75 grams and 20 degrees C, and I want to compare it to the ammonia curve. Well, the ammonia curve is right here. It's this pink curve. So am I above the curve, on the curve, or below the curve? Well, clearly, I'm above the curve. If I'm above the curve, what did I say about that? Then it's supersaturated. I'm going to abbreviate that with SS, supersaturated. Let's look at another one. If I'm at 130 grams of potassium iodide at 20 degrees. So first I'm going to find my 130 grams, and I need to find my 20 degrees. So I'm going to follow 20 degrees all the way up to 130 grams. I'm going to make a mark here. All right, 130 grams, 20 degrees. They intersect at this point. Now I'm going to compare this to my potassium iodide curve. Now I find that in all these crazy curves all over the place, and I see that it's right here. It's the yellow curve. Looks kind of like a line at this point. So is my dot above the line, on the line, or below the line? Well, clearly it's below the line. So if it's below the line, then that means I am unsaturated. Let's look at another one. 25 grams of potassium chlorate at 50 C. So 25 grams is here. 50 degrees C is over here. So my point is right here. I want to look at how does that compare with potassium chlorate. Well, here's my potassium chlorate curve. It's in green. It looks to me like it's above the curve. So since it's above, it's supersaturated. 70 grams of potassium nitrate at 50 C. So 50 C and 70 grams, looks like it's right here. 70 grams and 50 C. Now I want to look at potassium nitrate. So here's my potassium nitrate curve, and this point is below the curve, so you're unsaturated. Now I just want to point out, it's not on this right here, but I'd like to give you an example of a saturation point. Let's look at this point right here. What is the saturation point right here of ammonium chloride? Well, it's 50 grams of ammonium chloride at 50 degrees C. If that were my point, then it would be called saturated because it falls exactly on the line. Let's do two more examples. 40 grams of potassium chloride at 90 degrees C. So 40 grams and 90 C, we want those to intersect. C and 40 grams, okay? And I want to look at potassium chloride. Be careful because some of these labels get kind of crowded in here, so be sure that you're looking at the right curve. All right, so 40 grams at 90 C of potassium chloride. Here's my potassium chloride curve right here. So this dot is under the curve, so it's unsaturated. And 55 grams of ammonium chloride at 50 C. So 55 grams is right here. 50 C is right here, okay? So I'm going to put a dot right here. And then to me it looks clearly above the line. So this is ammonium chloride, so since it's above the line, it's supersaturated. I hope you're getting the idea. Please remember that generally, if you have a solid solute, if these are solid curves, they generally go up. They increase in solubility as the temperature gets higher, just like sugar in your tea. But if it's a gas, it generally goes down. So your solubility goes down as you get hotter, or you can think of it as you can store more gas in your liquids at cooler temperatures, like your cold sodas. Good luck.